have Yann from Microchip. He's a director at Microchip Technology. Yann is going to explain how solutions are scalable from 32-bit down to 8-bit microcontrollers. So counter to what might be conventional thinking that you need a lot of compute power to run AI models. His presentation, he'll cover a scalable approach on the hardware side as well. Yann is director for Microchip in Arizona, and besides leading the group developing capacitive touch technologies, he's also driving the corporate machine learning initiative across their microcontrollers and microprocessor lines. So, Yann, welcome, and the floor is yours.
Thank you, Chris. So yes, here today, just want to discuss, what you need to do predictive maintenance. So some examples is what Microchip is doing for machine learning here, and how we approach that is we want to make sure that every embedded designer can enjoy machine learning or AI ML, and to be able to scale it in the silicon for Microchip being 8-bit, 16-bit, or 32-bit MCUs. 32-bit MPUs as well. And not going to discuss that today, but we also have FPGA solutions here where we have our own, solution for maybe more the smart embedded vision aspect of it. So the goal here for Microchip is really to make it easy for people to use, and again, to make it for almost everybody to be able to design a new model based on data that they have created. And with that, of course, we help our customer to go through the journey here to make sure that they're successful in their development. So if we go to the predictive maintenance, so what do we have? Of course, is smart factory. We see that on robots, the machine vision, the human interface could be anywhere in a smart factory. So most of the time, it would be based on sensor like vibration, IMU could be also be sound. So if you're listening to a robot to understand if there's, strange noise, I would say. And also machine vision, which could be a very low-end vision of what the machine is doing, or very high-end, high-precision vision as well. So this is one aspect of where we see predictive maintenance. We see that also in HVAC application, and we just discussed that. So we see that in many, many applications. So one aspect that Microchip is really focusing on is motor control. So we have many, many applications for motor control, and we have many, many tools here. And one tool that we're also bringing to the table here is add, anomaly detection or monitoring using the IV data that you had to control your motor. So as it was mentioned earlier today, is how do we also do predictive maintenance without adding any sensors to it? And we have solutions here where, for example, with the DSPIC, which is a family from our products, we do motor control, and on top of that, we do the monitoring. So regarding the scalability of what we are doing here is, if you look at the type of products we have, as Chris mentioned, we can go as low as the 8-bit, and I'll come back to that. So, for example, if you have AMU, you can use that on an 8-bit. If you want to do something with more, a gesture or audio type, then we move to more like an M-core type of products, or what we call the DSP, which is our 16-bit with DSP family. And then the higher you go, of course, if you want to do, as I mentioned earlier, vision, then we move to the MPU side of things, or the FPGA family that we have. So the idea here is to offer a breadth of products to do predictive maintenance, depending on what you're trying to, which type of sensor you're using, and which type of application. So one big thing that people are requesting is for them to build their own model. So we can use model from already available, and I saw some very good ones today. But also some people say, okay, how do I build my own model? One thing that I want to mention as well today is we are, with what we are launching, what we launched a few months back is we also want people to use traditional machine learning, not only deep learning, because not everything needs to have deep learning type of models. So here we have a tool which is fully integrated and available for, I say, for 8, 16, and 32-bit. That's really the scalability that we want to offer our customers, and to have an environment where you do everything here. So I say people want to build their own model, but they also need most of the time to create their own data set. So they cannot find a data set somewhere, on anybody's zoo. So it's also a way for them to create their own data set. And we want to make it easy here, because this is usually the trap people are getting into, is they don't have the correct data set in terms of volume, quality, or whatever you want. So we really need to have them, to help them here to do that. So that's why we have launched a tool which is absolutely unique here, because it's a complete flow from data collection to deployment. So you see some example on the right for predictive maintenance based on vibration, where you can classify, create your classified the feature extraction and things like that. So that's what we want here, is you create your own data set, then based on the target of the silicon you have, being what you may already have in your application, you can use the tool to create the model for that. And we also have specific model already in the tool with a very small footprint and very low CPU requirements. So this is more for the traditional machine learning. We can also, with the same tool, do deep learning based on proprietary models or TensorFlow-like type of project. So as I say, here is really to have a model builder here, and to do it based on the target that you want to use in your project. Some customer, what they want to do, they say, I'm ready, for example, having my motor control with a DSP. Now, how do I add to it to have predictive maintenance without adding any cost? So in that case, it's just to have maybe a part with more memory, but that's what we want to offer. So trying to show here also some very simple demo. We have more demos coming, and we have more demos available as well, but I just wanted to show what we have on the low end here. And we have very small kits here where are based on the SAM-D21, for example, for us. It's an M0, doesn't matter the part number. But again, it's to have a very easy way for people to start with what we are doing. So what we have created here, for instance, is very simple projects from fine conditioning. So that can be used for any type of pumps. That we have some application on pool pumps, on HVAC, on different type of machinery in a factory. But this is the same kind of a project here, and we have that saying here running on any VRDA, which is the low-end 8-bit on our portfolio. Again, we have gesture recognition, because some people, that's what they want to use to do predictive maintenance, is maybe to recognize a robot movement, and at one point you will feel that movement is going off because the bearing is starting to wear out. So this is also another way to do predictive maintenance, and again, we can do as low as an 8-bit. So this is what I wanted to show today here, Chris, is the scalability of the project here. Basically, is how can I add predictive maintenance, maybe in most cases, to my project, which is already done, or how do I create a different, application which will use IMU, which will use audio, or which will use vision. So we can cover all the market here.
Great. Hey, well, thank you very much, Yann. And hopefully people can appreciate that these solutions here are not just the traditional convolutional neural nets, but expand to address a broader variety of machine learning approaches suitable to the particular use case.
Thanks, Chris.
Great.